Hello everyone, welcome back to our channel Alchemist. Today we are going to see the topic organic chemistry, that is the basics of organic chemistry. Okay, let's get into the video. Okay, in this slide we are going to see the introduction to organic chemistry. Okay, let's just start story how the coal was formed. Let's see. You must have seen coal. Okay, this black one is the coal. Did you ever wonder how coal is formed? Let's see. Years ago, when different kinds of trees, that is grass and trees, they died due to flooding and other factors like earthquake, etc. Okay, they got buried under the earth crust. With the passage of time and due to extreme condition of temperature and pressure and heat, these dead and decaying plants and animals too converted into coal. Okay, this is a story of coal formation. And then, okay, substances like sugar, starch, protein derive from plants and animals. Okay, these are from living sources and they belong to a branch of chemistry known as organic chemistry. And then, substances like sulfates, common salt, nitrates, they derive from minerals and they are from non-living sources. Okay, these substances belong to a branch of chemistry known as inorganic chemistry. These are the differences between organic and inorganic chemistry. Okay, and in this slide we are going to see the theories that are based on organic compounds. Let's see one by one. The first theory is vital force theory. Years ago, it was believed that the organic substances in nature, they are directly derived from nature. They cannot be prepared artificially in laboratory. That means some force in nature that helps in the preparation of organic compounds. That force is known as vital force and the theory is known as vital force theory. And another scientist, Hilary Rowley, discovered urea from urine of many organisms, including humans. And then the next scientist is Friedrich Euler. He synthesized an organic compound on laboratory. Let us see the reaction. Okay, this is the reaction. That is AgNCO plus NH4Cl gives NH4NCO plus AgCl. And this is an inorganic compound and he converted into an organic compound. NH4NCO, that is ammonium cyanide, is converted into urea, that is organic compound. This compound, inorganic compound, is unstable and urea is stable. As we already saw in the previous slide that Euler discovered an organic compound from an inorganic compound, that is he discovered urea from ammonium hydroxide. Okay, this is we already saw in the previous slide. So he was called as the lord of the carbon rings. Okay, and that was the end of an age. Okay, and then the vital force theory or vitalysis failed because the vital force theory states that it is impossible to synthesize an organic compound in laboratory. But Euler synthesized an organic compound in laboratory. So vital force theory failed. Okay. And then nowadays over 5 million organic compounds are present and the study of these organic compound or the branch of chemistry is known as organic chemistry. And organic chemistry is nothing but the study of carbon compounds. Okay. And then now let us see the examples that organic compounds present in our day-to-day life. The first one is the soap we use, and second one is the perfume we use, and third one is the clothes we wear, and then the fourth one is the drug we use, and food we eat, and then fuels we use, and then the last one is medicine. In all these compounds, the organic, that is the carbon, is present. Okay. And then, as we all know, the statement that is the carbon is unique. Okay. Let's see the characteristics of carbon. As we all know, carbon has a valency of 4, so it is tetravalency. And this is the main reason that it forms 4 covalent bonds. As we all know, covalent means sharing of electrons takes place. Okay. And then see this example, that is methane. Methane means CH4. Carbon binds with 4 hydrogen. Okay. As we all know, hydrogen has 1 electron, and in these 4 hydrogen, it shares electrons to become the carbon octet. Okay. See this, carbon has 8 outer electron, and also hydrogen is also stable, that is it has a doublet structure. These 4 hydrogen has stable, that is doublet structure, and the carbon has octet structure. Okay. It also be represented in the dot electron dot diagram as like this, and then structural formula, that is CH. In these 4 covalent bonds are present. In one covalent bond, there is sharing of 2 electrons, one from carbon and one from hydrogen. And then in this also 2 electron sharing, one from carbon and one from hydrogen. In this also 2, in this also 2. Okay. Totally 4 covalent bonds are present in methane. And now we are going to see the important property of carbon, that is catenation. Catenation means the self-linking property of carbon, and it is the most important property that it helps the carbon to link with other atoms. Okay. See this, it forms a long chain of carbon atom. Okay, up to n times, and there's a basic simple property, that is, as we already know, carbon forms 4 covalent bonds, and if you notice, in all the carbon there are 4 covalent bonds, and each bond shares 2 electrons, and carbon satisfies the octet rule. Okay, this is the basic rules for catenation. And then now we are going to see the types of organic compound. Okay, let us see the types. The first one is a straight chain or branched chain. It is otherwise known as open chain or aliphatic compound. Okay. And then the second one is cyclic. Cyclic, it is otherwise known as aromatic or closed chain. Now let us see the examples. Okay. Straight chain means the carbon is in the straight chain, and it is also known as aliphatic or open chain. And branched chain is also aliphatic, and it has a branch of carbon. Okay. In this, a lot of branched chain occurs in carbon. And the next one is a cyclic chain or closed or aromatic chain. Okay, it is in the cyclic form. And then carbon can link itself through single, double or triple bond. Okay. Okay, see this, the carbon carbon single bond, and then in this carbon carbon double bond, and in this carbon carbon triple bond. But as we know the rule, that is carbon has 4 covalent bonds. Okay, it 1 2 3 and 4. Okay, in this 1 2 3 and 4, in this 1 2 3 and 4, it satisfies the 4 valency or 4 covalent bonds. Okay. And then the next one is it is not necessary that the carbon can link only with carbon. It can also link with oxygen and nitrogen. Let's see, with double and triple bonds too. See this, carbon linked with oxygen through double bond. And the next one is nitrogen. Carbon links with nitrogen through triple bond. Okay, so it is not necessary that the carbon can link only with the carbon. It can also link with nitrogen, oxygen, etc. Now we are going to see the hydrocarbons. Hydrocarbon means the name itself says that hydrogen and carbon are present in the compounds. Okay, so it is known as hydrocarbons. And then there are two types of hydrocarbon, namely saturated and unsaturated. Let's see what is saturated and what is unsaturated. Saturated means only single bonds are present in the compound, and then unsaturated means there may be a double bond or triple bond. Okay, it is known as unsaturated. And then now we are going to see the general nomenclature for naming a compound. Okay, see this, it is based on number of carbons and the root word is given as. Okay, the first one, C1, if there is only one carbon, the root word is meth. And then if two carbons are present, the root word is eth. And if three carbons are present, the root word is prop. And for four carbon, it is but. And for five carbon, it is pent. And for six carbon, it is hex. And for seven carbon atoms, it is hep. And for 8 carbons it is op, and for 9 carbon it is non, and for 10 carbon it is dec. These are the root words, and this is a number of carbon atoms. Okay, if you have any doubts, put it in the comment box. We will surely help you out, and thank you for watching.